Okay, we have pretty packed agenda, so let's start on time. Welcome to 6-man session. Please take your seat. Okay, so this session is being recorded. It does not mean you don't need to pay attention. Oh, why? Okay, note well. I guess by Thursday we've seen it plenty of times, but still, please take a look. And particularly, please be nice to each other. No shouting, no yelling, only saying the nice things. That beautiful rule, true, necessary, kind. 2 out of 3 conditions must be met if you want to say something.
And there'll be a test at the end on this.
Okay. Housekeeping rules. I would really appreciate if when people joining the queue, even physically walking to the mic, they would use on-site tool whenever possible, because it does make the chair's life much easier in terms of keeping track of who was on the line first and so on. And don't forget to sign in using on-site tool, even if you do not going to ask any questions, because it basically replaces the blue sheet. For those who are feeling nostalgic, we now have a physical blue sheets which you can scan, and Bob is going here to send them around the room. Well, if you join in from your laptop, keep audio and video off. And yes, and please don't forget to put your mobile phones in silence mode. Would be really appreciated. Remote participants, well, as usual, yeah, please keep your audio and video off until you actually start speaking, and headsets are recommended, making audio much easier, much better. So yeah, we have a Jabber room, chat room. We have Meet Echo, but I guess you can find all those links in the agenda. We have minutes taker. Greg, thank you very much again for being volunteered. Agenda. We have some updates on the documents, and we have 4 working group drafts. We still talking about link local URI progress. Then we'll talk about architecture for IPv6 and non-broadcast access, IPv6 query, and my favorite topic, extension headers. And we also have 3 individual drafts. We're going to talk about how to make ULA work slightly better than they do now. We're talking about DHCP prefix delegation signaling to hosts and ICMPv6 loopback message. We also have 2 drafts in time, if time allows, category, so we cannot guarantee we get to them, but if we are good at tracking time and be on time, we might. So, document status. Nothing has been published since Yokohama. We have nothing in RFC editor's queue. URI draft. It was submitted to ASG and it caused some discussion, but we have it on agenda today. So I'm not going to spend time on it now. We're going to dedicate like 15 minutes to it after chair slides. We have 2 drafts which been in last call forever. We are sorry about that. For seed draft, the reason was during the last call, few issues been identified and corresponding issues were created in spring, for spring compressed seed draft. And we wanted to wait until those issues are resolved before advancing this one. Those issues just been resolved in spring working group this week. So currently this document is basically, we'll move forward with this document. We need to do chair's review and shepherd rates. And extension headers limit draft, yes, my apologies. So we kind of delayed this draft unnecessary. We currently doing chair's review for this one. I'm sorry. We have a number of working group documents. Hop by hop draft. It wasn't the working group last call. Some issues been raised, so we're going to talk about it today. It's on the agenda as well. Some of those working group documents are on agenda and some are not, because there's been not much progress on it, or authors have not requested the slot. Final thing as a reminder, I think we're going to show this slide for a while now. So this is about collaboration with other working groups and giving agenda time to drafts which are related to other working groups. Because we normally have very busy agenda, we prefer not to allocate slots to drafts coming from other working groups until it's adopted work, or chairs from other working group explicitly asked us, because sometimes we see in drafts which are related to IPv6, but this group might not have a necessary expertise and ability to decide if it's a problem which needs to be solved. So we normally rely on originating working group to tell us if it's something we shall be working on, right? So for people who'd like to propose agenda item next time, think about, is it actually 6 months specific or it's coming from other groups like Spring? And I think that's all for the chairs. Bob, you'd like to add anything? No? Okay, so first on the agenda, I guess it's your draft, right? I'm going to share slides just a second.
Hi, I'm Bob Hinden. I'm mostly speaking for Brian, who's in New Zealand, didn't make it here. Next slide.
Sorry, dismiss.
Yeah, so this is the basic idea, is to make browsers accept addresses like this, where you specify the interface to reach linked local addresses, and we continue to think it's a very useful thing in environments where there are no global addresses, which we have discovered there are some, are becoming more of, and for getting new devices installed. Next slide. So I'll and part of this is fixing the RFC that is currently published that is broken. The new thing we've discovered is the last thing on the slide here, is that NEMA has done a new version of marine networking, or networking for boats, not ships as I understand it, but recreational and not giant ships, but there's a whole industry around this, and they've done a new networking standard that is basically based on IPv6, and particularly for this conversation uses linked local addresses exclusively. So next slide. There are 2 open discuss ballots, and we are attempting to get these resolved. I think the first one we should be able to get resolved, because I think this is intended to be for devices that run web browsers, like Macs and PCs and phones and stuff. Most network infrastructure devices do not have screens and keyboards. They don't have web browsers, and I think that's how we can resolve this discuss. The other discuss is about feedback from the W3C community, and this is going to be harder. Next slide. There's been a number of updates as we've learned more about this and attempt to try to resolve the issues in the discusses. And so we're trying to explain it better. We added the NEMA use case and noticed, issues of MAC addresses. Next slide. And attempting to close the issues in the Rob Wilton's discuss. Yeah, I don't think I need to read all of these. Keep going. And then doing the same thing for the other discuss. Next slide. So the other thing that's happened, and I think well, Eric can correct me if I get this wrong. Eric organized a side meeting on Tuesday to try to talk about this. And the good news is that all of the authors and the internet ADs were there, but the people holding the discusses didn't come. And I'm not sure how much to read into that, but so we certainly are making an attempt to have a discussion about this to get these issues resolved. And I think the next step will be for Eric to bring this back to the ISG. Eric, do you want to say anything?
I don't really want to say anything, but I think I probably have to. I think the W3C objection to the any changes to the ABNF for the URL syntax. I've had several sidebar discussions here in person. Many people don't want to engage on this anymore. They say things like, I can't believe that's not dead yet, or I don't want to show up to that conversation because it would appear to dignify it, or whatever, or support it. I don't really know what to do. I believe we have done all the right things. I believe the text is correct. I believe Brian has been fantastic about taking feedback and responding to feedback, and that essentially, in reality, all issues have been addressed, but I don't know what's going to happen with respect to executing, I don't know, some discuss override option or risk people declaring war, open war will be upon us if we try to advance the document. So I'm going to try to close every one of those discuss points down to the last W3C one, and I'm going to keep trying to engage with the relevant ADs and other W3C participants. But I don't know what's going to happen if they refuse to budge. And I don't really know what I'll have to seek some advice from other ISG members and whatnot. But if the community wants to press forward, then it's quite likely that things could get much more interesting.
Thank you. Yeah.
David Lamparter, I just want to say thank you to Eric for doing this very annoying work. I do believe it is very important. I hope you can try to continue a little bit at least. And thank you.
Sorry, what was your name?
David Lamparter.
Thank you. Yeah, and the other thing I'll say, if there's anyone else who knows of any current use cases for this, like the NEMO one, please, let us know. We can certainly add that to the document, but it's also good to bring it to the ISG that, this is not just a theoretical future thing. This is something that we think is a problem that exists today. And as V6 moves into more things like this, we're going to see this more commonly, and the web browser is just a very convenient way to access devices. It's done a lot with limited scope IP4 addresses, so it should certainly be possible to do it with V6 addresses. Joel?
Yeah, Joel Yeagley. Were this standardized, I'm reasonably certain that I would use it for something other than a web browser. Right, because servers have lots of interfaces and interface scopes, and normally we distinguish those things with routing or source address selection or VRFs, all of those things. Sometimes I want to express which source interface I use in a URL, because then I can provide instructions to a machine by doing that. And that's not broadly dissimilar to discovering a resource via bonjour and then adding an interface scope to it in your application, which is the sort of thing that like a web browser would consume, I would definitely use this in other contexts where it's sufficiently standardized that like my HTTP libraries for Python, for example, were aware of interface scopes.
Good, thank you.
Can I jump in and reply? Sorry, Eric. Joel, you might run into the issue that Rob Wilson raised in his discuss. There was never any ABNF syntax for an interface name. Poop emoji 0 is a valid interface name. It's not going to work in the URI syntax without percent encoding. And so, gigabit 0/board 0/port 17 as an interface name doesn't technically fit the ABNF, either the current or the proposed revision. But scope identifiers will work, modulo the %25 problem.
Yeah, I mean, there's certainly some limitations there. Like, I think what is an interface is like a relatively complex question that your various servers may have differing answers for. For example, that could be an FW mark in a Linux machine, for example. So what you might actually stuff in an interface name, if you had recourse to this that would be meaningful to the machine, might vary based on what you were using it for. And like, I don't think that's inside the scope of this work, but like, if this existed, it would be a knob that like people would start to use because it existed.
Eric Niagara Nakamai. Another potential use case might be if you're looking for use cases, maybe in the DNS resolver space around with Do. But I think we're starting to think a little bit about that. That starts pulling on threads. Like there's a number of things in the discovery path for that that will then start also needing to convey information that may not fit into their ABNFs, and also I don't see the draft talking about how TLS gets handled today, but I think for this to be useful for HTTPS, there's going to be a bunch of things around how does this interact with SNI and how does it interact with cert validation that go beyond just the URL syntax, but start becoming relevant for this to become practical.
Yeah, I think that was not sort of the problem we were focused on, but that is interesting. Okay, thank you.
Pascal in the queue.
Pascal Tuber-Cisco. Yeah, I mean, Joel just mentioned that it's hard to figure out what an interface is, but at the end of the day, we own IPv6, so since we place IP address on interfaces, we should be able to define what we think an interface is because we have to place an IP address on it. So there is the machine concept of an interface, but then at some point that machine must present something to IPv6 that we agree is an interface. And so the fact that the concept of an IPv6 interface does not exist is probably our fault, not the fault of the machine. And so, I mean, as part of the work we are doing on architecture, it's important that we define the terms that we're using. And some of them are subnet, interface, links. I mean, we need to have clear definitions somewhere on what those things are.
David Lamparter again. I do need to disagree with Pascal because we do have a definition of what an interface is, because the API for sockets for IPv6 is some old RC, and it does have the scope identifier as an integer. And that's not how, I don't know if anyone does directly that, but most use cases, most operating systems present a different thing to the user to identify the interface. And changing this to use the integer scope ID that is actually in the RFC that define the socket API is not helpful either. But the only thing in my mind that is helpful here is to try to standardize what we have.
I'm not saying the opposite. I'm not talking about naming either. What we need to standardize is what we think an interface is, and it hopefully is based on what we effectively use in the real world. But have some words which really say, there is the best that we call an interface, even if it's obvious to everybody. Maybe it's not when we try to respell it.
Sorry, clarifying question. You're saying standardize what we think interface is, or what is the interface name is?
That was our discrepancy. I mean, I did not agree with that. We disagreed because I'm talking about what an interface is, and David was talking about the interface name, I believe.
Okay. No more questions, comments? Okay. Okay. Pascal, I think you are next, actually. I will start sharing the slides. Hold on. You want to, okay. Hold on. Wait, so you want to present from your phone? Or you want me to share your slides? I'll do that. Don't worry about that. No.
That's easy for us.
Yeah, that we can do. Eh?
I did it.
Okay.
Okay, and this is Pascal Tuber about the architecture for NBMA. And actually, part of the things that this document is trying to do is give a clear definition that we would agree upon on those things: interface, link, and pref and subnet. I try to write from my experience of those things as a developer in iOS, but we might disagree. So that's why it's so important that we place those words in front of the community and see if we agree on the terms that are listed there. I tried to find those words somewhere defined, and I could not. Maybe I missed an RFC that's out there. But even in the context of IPv4, it was kind of implicit. And the best definition I could find for a subnet is pretty much the mapping of a lower layer broadcast domain. And since we actually, in this architecture, we separate the subnet from the broadcast domain, now what is a subnet? And at the end of the day, the other thing that I found was, okay, a subnet is a /64. And after all, why not? I mean, if you decouple the layer 3 constructs from the layer 2 constructs, then the subnet is what you want it to be. And the usual thing is that's why you place your /64 boundary. So you place your /64 boundary wherever you like. Outside of it, it's your IGP. Inside, it is the SGP or proxy. And that's your subnet. So that's pretty much what this thing is about. I've heard a number of misconceptions about the work. I don't know if it's because the text isn't clear or it's just too much text to be read. But as the title says, it is for IPv6 over NBMA. If you are trying to apply IPv6 on a traditional broadcast or point-to-point link, you don't need this necessarily. It's up to you. I mean, it could be seen as a degraded case of NBMA, but it can also be what it has always been. Meaning that if you have a broadcast domain and your decision, your administrative decision is to place your subnet at that exact same scale, be the exact same one-to-one beast, then this draft is not telling you to not do what you always did, right? So it's not a competition to what we have. It is an extension in case you want to deploy it on NBMA networks. And there are cases of NBMA networks in this IETF, for instance, EVPN. EVPN is a very clear case of NBMA. And there are some at IEEE as well. The ESS for 802.11 is also a very clear case of NBMA. So you can always do tricks, and Wi-Fi does tricks, and EVPN do trick by proxying IPv6 to extend over the NBMA. That works. There are a number of issues that were found over time. So it appears to work until it does not, until you get cap case after cap case, which is what we get now. So that's why we think it's kind of useful to have this architecture. Next slide, please. Sorry for the long introduction, but just not to get the kind of questions where, is it competition to the existing? No, it's a scope that IPv6 is not in right now. So the document went work group document, and part of what, sorry, Laura.
Clarifying question. Is 802.11 in scope or out of scope? Because you said that 802.11 is NBMA, but you also said that this is for, yeah, clarifying question. Is 802.11 in scope or out of scope?
ESS becomes broadcast when you provide emulation for the broadcast, right? Which is what Wi-Fi does. Now, if you leverage that emulation, there are a lot of consequences for it. And so Wi-Fi requires the use, it's part of the .11 spec, the use of a proxy. And actually that proxy is not specified, but this architecture provides a proxy for Wi-Fi.
Did you say yes or no? So I'm sorry.
I'm saying yes, Wi-Fi is a non-broadcast network with a broadcast emulation.
Okay, so it's in scope.
It's in scope.
Okay, thank you.
Wi-Fi will work better if this thing is in place, and actually Wi-Fi has a spec that requires that this thing is in place, but just that we don't have our side of the equation. So part of the adoption game was to actually focus less on the wireless primes, make it more general, and also focus more on architecture as opposed to prime statement. So next slide, please. So the document still has prime statement. We have just extended it beyond specifically Wi-Fi. So you'll see there's discussion about overlays like EVPN. Wireless Wi-Fi is in scope, as we just said. There is discussion of what we call ND proxies. There are different specs at the IETF which are called ND proxy, and they don't do the same things. So we don't even have a good definition of ND proxy. There are issues with security. There are issues with sustainability. So they are all discussed. At the end of the day, it becomes, with this architecture, it becomes an administrative decision to decide, in the one hand, what your broadcast domains are, and in the other hand, what your subnet is. So you decouple the layer 2 constructs from the layer 3 constructs. For example, if you are using Bonjour to find a local printer, you want this local printer to be near you. But it might be that the address that you get is for the whole building. Like there are some very large campuses, people enter anywhere, and what you would like is they keep their address as they move inside the building, but when they send something to the printer, it goes to the most local printer, which means that Bonjour will find a local printer around where you are, but the subnet in which your IP address has been taken from is as wide as the whole campus. And this architecture allows you to decouple those two things. Next slide, please. So basically, there is, as you see, that's why I went to the mic. As you start defining stuff and operations, you look for the key terminology that you're going to use. And doing this, I realized that I could not find that terminology expressly spelled out somewhere. So I did my own to start with. So there are 4 things that you're kind of used to. Now, it's not necessarily the way I spelled it. So really, your review is intensively required. And then there is a 5th element, which is the subnet gateway protocol, which came out of the discussions. So basically, you can see it this way. There is a /64 boundary. Everything which happens with a smaller prefix size is classical routing as you know it. It's an IGP, it's whatever you like. It's classical. Then there is the /64 itself, which is kind of a special case. And for this, you have all the art of tethering, etc. And then there is everything which is below 64, longer than 64, inside the 64. And that's where the specs start to operate. So you can route to host addresses, or you can route to prefixes which are somewhere between 64 and 128. So any size bigger than 64, this architecture comes into play. And the core thing is because you're separating the broadcast domains, you have to route or proxy between the different broadcast domains. So proxy, yes, it works, limited application. And then as soon as you grow it bigger, then you're routing. Now the routing protocol that you want has slightly different properties than the IGP you're used to. For instance, it's closer to a MANA because there is a lot of mobility inside the subnet. So you want to always know where is the latest location of this guy and route there. So that's why we coined this term subnet gateway protocol. And the thing that came right after is what was called WIN before for wireless MD is now called subnet neighbor discovery. So what it really talks about is how you couple a UNI, which is based on classical ND, and an NNI, which is a routing protocol, so as to enable reachability over the whole subnet. And I had another question, which was a great and interesting question. Oh, but then there are protocols which want different kinds of reachability. Some of them want my broadcast domain, like bonjour, and then layer 2 protocol. But then Andy, for instance, wants to reach possibly the whole subnet or what. And effectively, that's what kind of cool. There is this RFC 7346, I guess, by Ralph, which explains that there is FFO2, FFO3, FFO4, FFO5. Right? There is admin scope, realm scope, etc. So for once, we have a usage for that. I mean, if you want to ping the whole subnet, like the /64, or reach that, then you use admin local, because now the subnet is purely administrative decision. If you want to reach something which is emulated, for instance, using a Wi-Fi ESS, then you have realm local. And if you really want to reach only this link on which your link local is valid, then you use FFO2 as always. So that's pretty much the kind of answers that you will find in this document. Next slide, please. So once we talk about what's the global architecture, I mean, this global architecture derives from real life experience. It is actually deployed with a certain framework, which is the framework that we have developed in the last 10 years, over the last 10 years for starting in the context of IoT. So this section here is basically explaining how you use a bunch of RFCs that are actually already there to make this work. Now, there are still some documents which are work in progress. And in particular, 6law just adopted the prefix registration one, which in my book is a great complement to what you guys are doing, Lorenzo and Jen. By assigning prefixes to the host, there is this kind of missing link between, okay, this host gets this prefix from some sources. It can be DHCP, it can be IPAM, it can be AutoConf, it can be another source, whatever provisioning system. This host gets this prefix. And then there are routers around which need to know that this host has this prefix, because now you want to set up your routing table. And there is a need of a protocol which does not depend on the EPAM or DHCP or a vendor-specific solution, which is what DHCP is today, right? There is a vendor-specific interface between the relay and the router. Well, you want something standard and independent on the IPAM on the one hand and on the SGP. I mean, EVPN, Lisp, whatever you run on the other side of the router. You want something simple between the two to just connect those dots. And effectively, those RFCs that we have, if you register a prefix, that connects those dots. And there's also its usage in the case of SNAC. I see that we have SNAC people in this room. So. Next slide, please.
Okay, sorry.
Last but not least, but I still need to work that section and get people to help me on it. We used to have an applicability statement explaining the different cases of wireless, depending on there is a MAC layer emulation of the broadcast or not, etc. Whether this architecture applies to the different wireless cases, because this document started in the wireless world. Now we extend to overlays, Lisp, EVPN, all sorts of things, pseudo wires. As we do that, there's also an applicability statement to write, which I did not do so far. So if people are interested in helping on the applicability statement, then yes, we need the applicability statement to everything wired. And finally, this little section 7 talks about another misconception. That is that it's either this or that. I mean, the way it's designed and the way we've made it for IoT is that you would add IoT devices one by one on an existing infrastructure where all the other devices use the classical ways, use Slack or whatever. And so that's why there is this RFC 8929, which is the one that the new .11 specs refer to. I mean, if you look at the drafts for .11me, they will speak explicitly about this RFC. And the reason is, it is effectively the proxy that enables the classical device to see the devices which do the registration as if they were classical device. The proxy does that. So you can place both sorts of devices on the same link, or you can start distributing, for instance, on the wireless edge, devices doing this, and on the wire, classical devices. You can even have more than one, what we call them, backbones, where you do classical ND and use routing with the SGP between them. You can build whatever you like. So you can see what we have today as still there, as being just one of those links. And that's pretty much it. I may have another slide. And so there are many, many discussions. I guess the first one, so we can talk and understand each other, is to validate that we have a terminology, and that includes interface, with which we can actually discuss. Now, the second piece of this document is, as you saw, there are 4 things, right? There is problem statement, architecture, framework, applicability, and there is even backward compatibility. I heard on the list that some people found it was too big. So I've got a question for you, and I had a question to Eric already because I presented that at 6LO. Eric, whether it needs to be split, whether it's better for the ASG to see a single document, multiple document. I guess you've got a to-do to come back to us on whether we need to split this document or even if it fits inside the charter of this group.
David Lamparter. So I do have a missing piece, which, sorry, I don't think there's enough on the treatment of multicast in this yet. So I skimmed through it. You're talking about how to make MLD work without using as much broadcast, but how to handle the actual multicast traffic is also something we need to think about. Maybe that's actually a separate document.
It is mostly a separate document, but it is in there as a reference to the separate document. So
okay.
we talk about the registration for unicast, well, for unicast addresses. Well, there is also one which password group plus core, which is close to RFC. Well, entering ISG state, where you register unicast, anycast and multicast address, because they have a special treatment in the SGP. So you need to tell it's those addresses, and then the SGP is supposed to support multicast. So the first stop, you replace MLD, which is a pull from the network and not fit for low power, by a push by the device. I'm registering this multicast address, meaning I'm listening to it. And then it's up to the SGP supporting multicast to get you the packets.
I'm a bit anxious about, you just said the SGP is supposed to support this.
If you want support multicast inside the subnet, your SGP must be able to do it. It's not supposed to transport FFO2, but it's supposed to transport FFO4.
Yeah, that's specifically what I'm getting at. I would be loath to leave a hole here.
Please, I mean, question on the mailing list, maybe if you don't mind, but yes, more words are in order. I take that.
Oh yeah, Eric's plural. Okay, so I said some things at V6 Ops at the mic. I tried to write them in a way to 6Man. I sent mail just now. I have a few thoughts. First of all, that it's really, really complicated and really, really long. So I still am not able to read it. And I tried to skim it, but so I don't know if that's because we're trying to do too much or because it's just too complicated. I do think that it is very complicated, and I think it's, for most links, it's basically well past the point of diminishing returns. I have some thoughts over that, some concrete thoughts. ND is just a protocol that runs over broadcast links. There's other protocols as well. If we want to continue to run those protocols on broadcast links, because app developers find them useful, then the layer 2 has to continue to provide that abstraction. So we can't like get rid of that abstraction.
We don't get rid of it.
But then what's the problem with ND? Because I don't think, even in Wi-Fi, you say, well, we have ND proxying, but in practice, you could get rid of pretty much all of the problems if you did some amount of multicast looping coupled with unicast to multicast conversion. Well, it is like, arguably, you could say it's hacky.
We do and keep hitting customer issues because snooping is not reliable. That's the bottom line.
Well, maybe we need to fix
We
that,
want a contract so that the host and the router are both happy that the host will be served exactly like it wants, and the router is able to do that. And Slack is not that contract.
And
we discussed that on the mailing list times and times.
And that brings me to the next point, which is the current architecture has a very a balance that we arrived at after a very long years of discussions and tussles and so on, which is that hosts can mostly do what they want, and if they do things that are too bad, then it stops working. And this one of the things, more precisely what I mean is, like, in the current architecture, hosts are able to form addresses as they please whenever they please. And
it ends up not working if the routers are unhappy with it, and nobody knows until it fails, right? That's the current state
but
of art.
we don't have a lot of operational issues caused by this. So
I saw some, to be honest.
Some, yes.
Because I'm on the router side. Maybe on the phone side they don't tell you, but on the router side they tell me.
No,
I get cap cases.
Yes, right. But I think, so I think though in general it's like, we have a saying that we're just going to have like the router say no when it runs out of state. That's also a problem. And we have 7934 talks about that, right? So it's not as easy as saying, oh yeah, we just have a clear thing. The host says I want an address and the router says yes or no. There is
a little bit more, yeah.
Yeah, it works technically, but in practice, like sort of in terms of like architectural implications, it's pretty complicated. The 7934 says why. So anyway, so I think for general purpose link such as Wi-Fi, I think this stuff is at best, the benefits are at best tenuous. And it's really complicated compared to what we have now. You mentioned that the subnet abstraction isn't written down. That's because it's so simple, you don't need to write anything down. It's basically you send a packet and everyone gets it, right? We didn't write it down in 1998 because there's almost nothing to write. But this is very complicated. So I would also say, do we need all of this complexity in general purpose links? We have it for 6LoW, things that were really in low power. Yes.
So define general purpose link, because we replace a non-defined term, but yet another. I'm seeing what we deployed today, and no, it's not, you don't get what you just said. We try to emulate it because we have to retain that very old abstraction of IP to make it look like it mostly works. But it does not at all work the way you're describing. If you look at an EVPN, pseudo-wire, Lisp type of network, it's not at all what you think it is. It is what we still try to make believe it is, but it fails and fails again.
I think you'll have to be more specific about the failures then.
Well,
what is the big problem?
Having a node that you think is there, but is no more. You're having an address in your tables, but it's no more used. Missing an address and not being able to deliver a packet because you don't know where the guy is. Those are the failures. It's all written in the first section.
Okay, just for sake of time, I suggest you take it offline on the list. Eric?
Yeah, I'll try to be brief. So, but I think that, so I haven't paid closely attention to this draft recently. I did spend some time this morning trying to find definitions because I thought that there were sort of updated, succinct definitions of some of these terms. But after going through this half a dozen RFCs where I thought I would find them, I didn't find them. So there might be some utility in trying to write this down a bit more with a bit more detail, but I think that that's still should be a page of text just for the definitions, right? And that's it. In terms of the scope, the way and the current title, I think it's actually problematic because it comes across as this is it. This is replacing the architecture with something completely new.
I'm sorry, that's not the intention.
Hang on.
Yeah.
I'm trying to but because you need to actually clarify the applicability. We clearly have examples where we built a set of tools for 6LoW, etc., right, that are useful in some context, which is fine. But then sort of saying, and they might be useful in other future contexts as well, right? But I don't think that this is the NBMA architecture, right? I think it's useful in some of them, and part of that might go back to what Lorenzo was asking, sort of, do we have enough concrete about what are the problems we're seeing today, right? And sort of, I don't know to what extent how people configure EVPN, whether these issues show up, right? Where are the places? And I think the third thing is, again, trying to be brief, is, yeah, if we're gonna do something here, we have to figure out how to be a lot more succinct and sort of know what problem are we trying to solve, right? And we're not gonna do that at the microphone here today, so.
Okay, Eric.
Yeah, so I haven't had a chance to like formally revisit anything I've mentioned since the 6LoW chat, but for everyone else here, I was just kind of like, it feels like other things besides neighbor discovery must have also difficulties when you have changing broadcast and multicast scopes links, not just neighbor discovery. If you want, I said at the time in 6LoW, if you want to redesign the interface between L2 and L3, that sounds like a big thing. Michael Richardson pointed out to me that nobody ever designed the L2, L3 interface. It's all just assumed to be a big yellow wire. It seems like a fair point, but it does seem like the thing to do here is try to get some consensus on a different L2, L3 barrier, and sort of like difficulties with ND could be a motivating use case, but other protocols must also have this same thing. And if you got some consensus on changing or revising or creating a new L2, L3 interface contract, we could revisit what the implications of that are after that was had some consensus.
Okay.
Would be my guess.
Cool. Thank you, Rick. For sake of time, yeah, I think thank you, Pascal. We just ran out of time. We'd like to be on time. So the next one, okay. Thank you.
Hello, everyone. This is Xiaoming speaking. This draft is about IPv6 query for enabled in-situ OEM capabilities. Next slide, please. This is a recap of this draft. This draft defines ICMPv6 extensions to achieve IOM capabilities discovery in IPv6 networks. This draft is a companion document of IFC 9359. This draft defines IPv6 node IOM information querying mechanism. For this mechanism, 5 IOM capabilities objects are defined. Next slide, please. This draft has been presented at IETF 112, 114, and 115. Some good discussions happened. After IETF 115, this draft was adopted as a working group document. Here, I want to express a big thank to the working group chairs and all folks reviewing this draft. After this draft was adopted, we have revised it to the 0.01 version. The remaining 3 updates. First one, IOM incremental tracing capability object was removed. Second one, 2 examples of the node IOM information query were added. Third one, we clarified how this mechanism works in an ECMP scenario. Next slide, please. This is the first update. To align with the IOM over IPv6 encapsulation document, the C-type value 2 assigned to the IOM incremental tracing capabilities was removed. Next slide. This is the second main update. 2 examples of the node IOM information query were added. Among them, the first example is to query the default namespace ID. The second example is to query the 2 provisioned namespace IDs, which is namespace ID 1 and the namespace ID 2. Next slide, please. This is the third update. It's about how to use this mechanism in an ECMP scenario. Actually, the feed sharing has already been discussed before, and a paragraph is already there in IFC 9359. For the convenience of the reader, a sentence about how to use this mechanism in ECMP scenario was added to the end of the introduction section of this document too. Thank you. Next slide, please. There's a a open question. What category does this draft belong to? Experimental, standards check, or others? This question was first raised at IETF117 when this draft is still an individual draft. Now this draft is already adopted as a working group draft, so I think maybe it's time to consider this question. Next slide, please. Next steps, we ask for more reviews and comments, and we'll revise this draft to improve it. And maybe after that, working group last call. Thank you.
Okay, David?
David Lamparter. There's a known class of security issues where things respond with a larger size of packet after just one small query. Was there any discussion on this of requiring the query to be sufficiently large as to just impose a cost on the sending entity so they can't use this for amplification attacks?
If I understand your question correctly, you mean that the reply message is a big message containing many contents?
Yes.
So
you can, some other protocols have done this by just requiring that the query is large so that the response is not giving you this multiplication. So it's a defense against using this with a small query to get a large packet. Instead, you require a large packet to get a large packet, you know? So I don't know if this was discussed before.
I think there's no such a discussion still, but
that might be worth having.
I'm happy to discuss that with you. Yeah.
Yeah, so I read it as, yeah, we need some text on security considerations. I just have a comment, so I put myself in the queue. Yeah, the status is an interesting question because it looks like you're updating a standard track document, right? Your document is saying that it updates 4884, which is actually standard document, right? So I guess it will be
4820.
Okay, your document currently saying it's updating. Oh, sorry. Updates 4620 and 4884 as well.
Yeah.
And 4884 is standard track document. So if you're going to update standard track document, I think, yeah, we need to need to make this standard.
One
right?
of the FC is experimental.
Yeah, and another one is standard.
Yes, yes.
Yeah.
I think it should be the higher one.
Yeah, it should be the higher one. I don't think experimental stuff would update standard track.
Okay. I'm not experienced in this.
This doesn't happen.
Okay, so I'm actually curious. Can we get? I want to do a quick poll. People, so yeah, I'm curious how many people actually have read this or one of the previous versions. If you have on-site tool handy, please click on the button. I'm going to give it another minute or so.
So raise hand if you've read it. Click do not raise hand if you have not.
Yeah, I probably didn't phrase it very well. Yeah, a few people. Yeah, so well, I think we'll take it to the list. Yeah, thank you.
Okay, thank you.
Thank you very much. Okay, got it.
Corey, you're up.
The floor is yours. Okay.
Excellent. Yeah, okay. I'm going to stop here. Looks like it is. Thank you.
So apologies, first of all, we managed to schedule this in parallel with TCPM, which I've just been pretty working in. So I'm not quite acclimatized to 6-man, but I'm going to get there. I'm Gori Fairhurst, this is Bob Hinden, and we have been editing the IPv6 hop-by-hop options processing procedures. Next slide, please. I don't have a clicker, I have a coffee. Well, there's been progress, yeah, that's true. And we've done a number of revisions. So we're going to talk about changes from 0.6 to 0.7 and from 0.7 to 0.8. And a key thing is we're going to discuss the summary of updates to H200. And then we're going to ask the next steps about what to do. Click. We had a working group last call. We'll publish 2 drafts. The authors think mainly after the working group last call, people read it and then they kind of thought about it, and particularly Ole, who had some really harsh comments, which I hope were addressed by really restructuring and making the document much more readable and more clear in what its intents were. So we really appreciate that working group last call, and that's good. Thanks. Next, click. So we've oscillated on whether this document updates 7.045. Yeah, and it no longer updates it. Read that draft if you like. H200 also absorbed text from there. We added additional clarifications to the background, which were important, and we did editorial changes. This was a 6 to 7 draft. Next, please. 7 to 8, we did more, where we... Why did we do all this? This is mainly to be consistent, isn't it, across different things? Because when you restructure the document, you realize that there are a number of topics that come up in different places, and we really ought to have, no, we really should have with a capital SHOULD, language that matches when we discuss the same thing twice. So I'm talking so you have time to acclimatize to the long list of things here. Most of this is already implied in the RFC series somewhere and is now explicitly called out in a consistent way with the appropriate level of requirements in this draft. We added section 6 that new hop-by-hop options should be designed expecting that routers might drop packets with the new option. So what we're trying to do is unpack here a little bit the expectations that these things can be used, but they might not behave in the way that the original H200 and previous IPv6 specs said. But don't be discouraged from that. Just realize that if you send these things on some packets, those packets might be dropped. And if that happens, then design it in a way that lets your application carry on and do good things. Maybe the next network you encounter won't have that problem. And that's all to do with the examples of robust usage. The rest was trying to be clear and readable. Anything to add to that list, Bob?
Yeah, I mean, I think our conclusion after coming up with these changes is the particular talk about what you have to do to make a new hop-by-hop option useful in the current internet where they may or may not get to the other end or they may not be processed. It's actually very important advice for anyone wanting to define a new hop-by-hop option. You can't just define the bits and send it and hope for the best. You have to be more active about detecting what's going on with packets with those options.
Tom, was that related directly to draft 6, or can I get through all the changes first?
Clarification on that point.
Yeah.
So the expectation is that routers might drop the packets because of these new options, or just generally they're dropping packets with options?
So the section is written from the perspective of you want to put a new option on a packet. You should realize that routers can be configured to ignore those options because they be configured not to do options processing, or they could discard your packet because it contains that option or any extension header. I mean, it just basically calls out that you can't rely on a path doing what you expect. You should try it and find out.
Right, but I mean, it's a general problem. We're not saying if somebody adds a new option that says ignore, if you don't understand it, we don't expect routers to just ignore that advice and start dropping it because they don't like that option for some reason, right?
We explicitly say to router vendors, don't do that. Please forward packets even when you don't like them. When you don't like this option here, and just don't process the option, just behave like you're configured not to process it. Does that make sense? The advice is different depending on whether you're trying to use that new option, in which case we say, try it, see if it works, but don't rely on every path doing what you expect. And router vendors where we say, no, don't drop the packet solely because you see an option which you don't like. Of course, for security reasons, you might do all sorts of other things. And that's a different matter. This is just about the routing processing.
Well, it's one thing to design with the possibility that they drop the packets. But again, obviously we want to reiterate, you should never drop packets because of the option.
So
that's
please,
what it says. Yes,
yeah,
thank you.
Please read the new section and comment on that. There's more to it than what we hit the words on the slide.
Okay. We just go for next slide now, Bob. Yeah. This is more important. So as we think we are ready with good text for the draft, which should now be easy to read, hint, please read it. Let's present a summary of the updates to 8200, as 8200 is the full standard, and we want to be clear what has changed. This is not a different list to what's in the draft, but it's an explicit list related to 8200. So we'd like to go through these carefully. Number one, if routers do not process the hop-by-hop option header, they should forward the packet normally. Don't drop. Number two, routers should treat options they can't process with action bits of 00. In other words, whatever the option bits in the action field say, please forward the packet. Obviously, not if it's a security problem, but if you're a router and you don't know what to do, forward the thing. Otherwise, the packet will get dropped and things will start breaking in future and we'll never get anywhere. And because of this, number three is we changed the definition of 01, 10, and 11 because these bits don't make as much sense as they used to do when we believed that all routers would look at all headers and behave exactly in the way we said. Now, routers can be configured to ignore these or to ignore all extension headers. They might not give you ICMP-v6 back for this, or you might not even get it if they sent it to you. So these bits become much less meaningful than they used to be. So the definitions have been updated in this document. I'm going to get to the end of the slide and then take Ron's comment. Sources sending packets with hop-by-hop options should use a robust mechanism that assumes only one hop-by-hop option would be processed. Basic requirement, meaning basic. Please do more. Please allow many, but you should expect that one works. Add specific rules for creating hop-by-hop options. In other words, here's a section 4.8 that says in RFC 8200, let's now update that to say exactly how you create new options. Ron was in the queue first.
Yes, so is it your, would you like to take questions now? You have more slides. What's your, Tom, do you have clarifying question or your more slides? Okay.
If Ron's comment is on 8200, then please give it now.
It's okay, I can wait till the end.
Okay, so, we made what we think are lots of improvements. It's always good to get more people to review it. We think it's much easier to review and read, and we think it's ready to advance. So that was our next slide. So now we want comments. Ron?
Okay. I've been thinking about this for a good many years. I've worked on the problem a little myself, and my thinking has evolved. Please don't hate me for bringing this up this late in the game. The internet is really composed of a bunch of limited domains, and each limited domain has its own routing policy, its own forwarding policy. And one limited domain should not be able to affect another's, especially from the inside out, the way a hop-by-hop option does. So a hop-by-hop option inside of a limited domain is a perfectly good thing. And the things that you're working on make perfectly good sense. However, all the applications of hop-by-hop options that operate on the broader internet across limited domains tend to be bad ideas and tend to be security disasters. So it might be a good idea just to say the hop-by-hop option should always be filtered at domain edge points.
The option should be filtered, like you take out the option from the packet and forward the packet?
No, you
or
throw the packet on the floor.
The packet should be filtered.
On the floor.
And then basically I break the network down to smaller and smaller parts because I work with the other operator who I currently have a close relationship, and I'd like to be able to work with him and actually send OAM and things across the path between us.
Okay, in that case, what you have is an agreement between consenting adults, and the limited domain between those two operators is actually a single limited domain.
And it gets bigger. I'm not sure I agree with the comment you've got. I would like to hear other inputs.
Promiscuity is not a good thing.
Does it not depend what the hop-by-hop option contains?
Well, hop-by-hop option is fine inside a limited domain. It's even fine inside a limited domain that is controlled by two operators. It's just not fine in the wild.
Why not?
I'm sorry, could you say that again?
Why not?
Because by its very nature, the hop-by-hop options, or at least the ones we've defined so far, change either routing or forwarding policy of another from the inside out. So they do things that normally the operator of a limited domain wants control over. For instance, the router alert option, you just don't want to accept packets in your domain with the router alert option from strangers, or for that matter, any other hop-by-hop option that we've seen in the past.
And in the future, that's also the case? Because this is about the future, I guess.
Yeah, if you want something from an operator, ask for it at the network edge, and the operator will do something about it. But going under the covers of the network operator, that might be a little bit too intimate.
Let's talk about that on the list if we could.
Okay.
We've got a little queue building here.
Yeah, Ron, sorry, I guess we can take this to the list. Suresh?
Yeah, thank you. Suresh Krishnan. So I read through the draft, Corey, looks good, right? Like, so there's a couple of, I think, unintended side effects in the updates to 8200. So one of the things is 8200 doesn't follow BCP 14 language, right? And the updates do. So you are using uppercase may when the rest of the document doesn't. So I want you to think about it. And there's one specifically bad case where the option type is 10. It's talking about like two mays independently. So one of them is like dropping the packet or not, and also gives an option to either send an ICMP about it or not. So I kind of want you to, yeah, Bob, you look surprised.
Could you send us email on that one? Just
yeah, sounds good. I'll do that. So there's like two cases, like, but I think I don't like want to open this like uppercase issue again, because like I was the AD for that one and it was not fun to open that case. So
right, remind us on that, because we did read those sentences and have that discussion. So yeah, remind us. Thanks. Be quick, please, in the question, and we'll try and move on. Is that okay?
Yeah. Tom Herbert, just one quick clarification. So the assumption when we're sending hop-by-hop options that one would be processed, I think the assumption really is 0. When we send with hop-by-hop options, there's no guarantee that any node in the network would process those.
Which bit of the document are you actually commenting on? Because we spend all the time articulating through
number 5 or whatever on that previous slide.
Yeah. Send us a comment on text.
It's always something I was a little fuzzy on, exactly why 1 is a magic number. but the way I see it, it's anything from 0 to all the options in the packet may or may not be processed by any or all nodes in the path. So fundamentally, from the sender's point of view, it's best effort. These may or may not be processed, or they may be processed completely.
Send us a comment on particular text, please.
Can you go back to the, Lorenzo Colletti, can you go back to the 8200 slide?
Yeah, let's go there.
So I think this draft upset, this text, I think the text that upsets Ron was like forward the packet text, right? So
forward the packet text.
That, yeah, so I would think there's a couple of things I think you could do to improve that. First of all, you could say something like forward the packet based on the extension headers that you see after this. Because a lot of the time, I mean, a lot of the damage that was done by extension headers previously was like edge filters just saying, oh, I can't look past the extension header and see TCP, so I'm going to drop it. So this language doesn't, depending on how carefully it's worded, this might basically say, oh, you don't understand it, so forward it, even if it has a header that you don't like later. So instead it should say, go look past it, maybe.
Well, so can you try reading the text carefully, because we agree.
Yeah.
So read the text, because we try and write words
Ron,
that said that.
Maybe Ron didn't read that.
Yeah,
I know.
The text in the document is particularly just talking about hop by hop headers, not don't look, just.
But there's stuff after them, right?
It says forward the packet normally or something. So see if that is close to what you want.
Because the other thing that an operator might be worried about is not just like, what's after it, but could this thing get past the security filter and then do something dangerous after that? So if there's some way of constraining what the header can do later on, then there might be a compromise that you can find with people who are trying to do this in edge filtering. Because otherwise, I mean, I can see two different points of view. It's like Ron says, I need to protect my network, and you're saying I want to do something new tomorrow. Yeah. And if you can't find a compromise, I think it doesn't matter what this says, the headers will get dropped anyway. So
super important. Please have that discussion with us if you could.
My colleague Remsen. So one of my long-term pet peeves have been the word filter. And in this case, it's configured, because a lot of the times the operator doesn't really have the option of design, and there's no intent to do one or the other. It's handed down by the manufacturer who has designed the thing to do things in a certain way. So talking about configuring and filtering conveys an intent that often isn't there. So I would like to, well, it's my opinion that there are multiple places in the document that could be revisited and try to figure out if it claims that there is intent where there might not be. Does that make sense?
Yeah, and love comments that on the document when we via email or something, because I think the problem with the document is it's for people who are trying to use extension headers. In the future, perhaps even, because I mean, like, there's only a couple designed that are useful. It's about operators who are trying to put these into networks, but equipment vendors and what you're asking them to do. It's about designing forwarding logic. It's about many different things to many audiences, and getting that right is important, because otherwise the document's no use to anyone.
Yeah, because I just don't want operators to be the scapegoat here when we're not the only one to blame, right?
All right, let's check we get the text right. Okay. Hello.
Tim Winters, QA Cafe. So I asked for a lot of this text. Thanks for putting it in for the don't drop. I think this is good for routers. I know Ron is not a fan of it, but there was a lot of confusion around this. So I think my biggest takeaway here is we should resolve some of this. I did also notice the same inconsistency that Suresh did. I'll send the same note to the list.
Okay, and could you also check the text just in case Suresh doesn't do it quite right?
I will.
Thank you.
Okay, thank you, Gore. We are on time, and I think what
Were you going to do another?
Yeah, thank you. Yeah, so I think the idea is we might want to do another working group last call for the updated version, which will issue after this IETF. So please stay tuned for the working group last call announcement. Please read the draft and provide comments, suggestions, text updates, and so on.
And Bob and I probably with a week or so's vacation after the IETF, can try and roll anyone who's got immediate comments that we just brought to the mic here. If you've got text proposals, get them to us quickly and we'll get a new rev out before that last call.
Okay, so yeah, I'll wait for.
Well, if there's a rebound on this meeting directly, then we will do a rev, so in a few weeks, and then do working group last call.
Yeah. Okay, and I think now we are moving to individual drafts, right? Okay. Pencil go down. Okay, let me. Oh, team, yes. Oh, beautiful. You can go while I'm trying to find the slides. Oh, it should be dramatic entrance, and you cannot go until I get slides. How many minutes?
All right.
20?
So Tim and I are gonna tag team this one here. So we're gonna talk a little bit about how the preferencing works for ULAs in RFC 6724. Next slide. A lot of this was discovered in my role as migrating the Department of Energy off of IPv4. And during that process, there's a lot of different networks and a lot of different things that you see, and the transition period of running dual stack sort of highlighted some of these issues. Starting to dig a little bit deeper in this, we realize RFC 6724 is like 10 years old. It's more than 10 years old now. So, and operational experience has been ramping up dramatically over the last couple of years for a number of different reasons. What that's shown us is that there's a lack of configurability in the address selection policy, which is very important to the transition process. This draft is pretty simple. It provides a specific example involving ULAs and RFC 1918 addresses, and it essentially aims to demote IPv4 further down, making migration to IPv6 only much more simple. And the other thing we discovered sort of anecdotally is there's still a whole bunch of RFC 3484 implementation that's out there that hasn't been updated, and that's we've had 10 years to do that, so that should get done as well in this process. Next slide. All right, so the problem is really laid out in the IETF v6 ops draft that's linked there. You can read through that if you want to. It lays out there, it solves no problems. It just lays out what the issue is. But really the crux of it is that there's policy table adjustments that need to be made. The emphasis here is really on configurability with RFC 6724 and the fact that there just isn't enough of it. It's not easy to do. And it makes it really difficult to implement some of these changes that we need to do that are, sort of in the path of turning v4 off. So Tim's going to talk about what we're proposing to do here, and I think it'll be a lot more clear once you see what he has to say.
Or will it? So yeah, just to emphasize as well here before, well, move on to the next slide anyway, but just to emphasize, we're not proposing a full 6724 BIS. Having been involved in the 3484 BIS, I don't think I would wish that on anyone. So there's basically 3 fixes, although it turns out, in fact, there's only 2. I'll explain why in a moment. So the first one is to change the default policy table so that we're elevating the precedence of the ULA prefix. There's a little side thing there where we would also relegate the old 6 to 4 prefix as well. So maybe there's 2 things in one here. But the important thing is that then when you'll get your destination address selection, you're going through the comparisons, you're going to put ULAs ahead of both, well, at all v4 addresses, but including the 1918 addresses. So that's the first fix that we can discuss shortly. Next slide. I'm trying to keep these slides as short as possible so we can have maximum discussion time. This is a little tricky, the configurability. As Nick's explained, there are good reasons why you would like the policy table to be configurable, and yes, there is a DHCP v6 option for that, but I don't think it's very, very minimally implemented. There's also no way of doing it with an RA. So at the moment, we would like to see more configurability. We'd like to elevate the should to a must, but at the same time, if you're building some very constrained device and then lobbing it into the earth somewhere and never going to be able to configure it again, the practicalities of making it a must. What we'd like to do is get your input on how we can make more vendors, more implementers, make these things more configurable than they are now, I think. And next slide. So this first one actually isn't a fix because it's kind of already done. So this is a bug. And in fact, rule 5.5 is a must anyway, because it inherits the must from the start of section 5. I think Nick and I are getting a little bit confused is the wrong word. I think this is a symptom of there still being 3484 implementations out there that aren't 6724, because 5.5 was an addition between 3484 and 6724. So we've seen from experience that this is a good heuristic and it helps. And I think what we're trying to do here is really emphasize that it's important, and that maybe what we're really saying is, if you're only doing 3484, please, please, please do 6724. So I think that's all we want to say. What we'd obviously, sorry, oh, sorry, there's one more slide. Okay, so you've had a lot to say, or the list has had a lot to say. I counted over 300 messages about both this whole topic about what we can do. And there's been quite a few comments, and I've picked out 3 of the sort of strands of the discussion that we're going on there. So one of them is around how we deal with corner cases. I think what's underlined there is that the thrust of this draft is not to make this perfect, but to make the common cases behave better than they do now. So there will, I think the list agreed, there will still be corner cases that may require configuration or explicit configuration. Let's just make it better. There was a part of the discussion was around it would be maybe useful if hosts could automatically, when they observe a specific 48 ULA prefix, add that to the policy table. And I think there's a good argument as to why that would help then with the address selection. That's something we could also consider and discuss, but at the moment that's not being proposed in the draft. And there was also a suggestion, I forget who by, about adding a PIO with A0 and L0. And I think that's maybe a bit of a stretch of the RFC, but it might be the basis for doing something to build on for auto configuration and configurability with auto configuration. So I think that's definitely the last slide.
No.
Oh, all right. So that's the discussion slide. It's effectively the last slide. So, so the first question is: are we, do we agree that this problem is a problem and we should fix it? And that these 3 or 2.5 fixes, if you like, we're proposing are ones that are worth doing. And do we, if so, do we want to adopt it, whether we agree or not, and what the fixes are, to at least adopt it and work on the problem from here? So that's it. Nick and I will now take questions.
Lorenzo?
Can you go back to the policy table slide?
No. No.
It's like slide 4.
I find it pretty amusing that you don't even consider the existence of public IPv4. And I also find it quite amusing that Teredo is not 1. But
They're all lumped together.
I don't object to any of these. I do think Teredo should be 1 because, but well, it really is amusing that you talk about RFC 1918 and you don't even consider that a device might have a public IPv4 address. But that's not, CPEs do, for example.
Yeah, well, so that's
anyway,
really an artifact of just me speaking, because there's really no difference between them from a source selection process.
Yes, if you want to go back to the question slide, I think I agree. I think I agree with let's just make it better. I mean, I do think we have a tactical issue here where, ULA to ULA should probably be preferred over V4 to V4. And I would suggest let's do that and let's get it done. And let's not, and then maybe let's put everything else in another draft. For 5.5, I agree that 5.5 is necessary. Nothing we say will do anything here. But if any entity might have the possibility of funding a change to Linux, I would love that to happen, right? I can't very easily justify us going out and coding it, but if somebody coded it, yeah, it's obviously necessary. The configurability, yeah, I don't think we should do that. you don't want networks saying, oh yeah, you should prefer IPv4. I mean, I don't think we should do that. I think we should fix it. And if configurability is necessary, then I feel that that's kind of a symptom that something in the architecture is wrong, or the deployment scenario is very sort of unusual and likely to hit unforeseen problems, which will then lead to other issues. So I wouldn't make it configurable at all. So.
I mean, I think that the underlying goal here is for the sort of networks that Nick's been particularly dealing with, it's to get rid of v4. And if they're going to run dual stack and we do ULA to ULA rather than v4 to v4, then once they observe there's no v4, then it's, they're going to be a lot more comfortable turning it off, I think. So it's the whole thing here would help, I think, with getting rid of v4 and going v6 only in those sorts of networks.
Yeah. I put myself in the queue. Genlinko, first of all, yeah, second to what Lorenzo said, Rule 5.5, it's like basically things almost every enterprise actually dreams of. And I know more and more operating system implements this, but yeah, we definitely need it on Linux. It would be just like Christmas. So just a minor comment about must. I would be, no hats on, right? I would be very careful with must, because I always think that must or must not means if you don't do this, a lot of bad things happen, right? It's not about convenience or optimization. It's about actually really breaking something. So I'm not sure we can
happen. What if you don't have 5.5?
No, I'm not talking about rule of 5 must. I'm talking about must support configurable things. So like it's about convenience and optimization. Connectivity is still there, but you might not like achieve what you want. So I'm not sure we can justify must here.
So what we're basically saying is let's change that default table, and also let's promote more people to implement 5.5 and promote more people to make them configurable. So whether that's a must or whatever, that's what the document's trying to convey. Yeah. But the question is, how do we word it? How do we
we'd like you to make it configurable. For me, sounds like should, right? Because I might have reason not to.
Yeah, there's nothing in between must and should, is there? But that's kind of where we want it to be. Like
should 0.5. Okay, yeah.
Kyle Rose Akamai, I already gave my opinion about should versus must on the mailing list. But the real reason I'm standing up here is since I'm the person who apparently lit the most recent dumpster fire on the mailing list, I just wanted to reiterate Lorenzo's point before about, I think it's really important we get the default policy table updated as quickly as possible, specifically because I can't remember who it was, but somebody said before, everybody should update to 6724. Please, no, do not update to 6724. Let's get the policy table fixed first and then get everyone to upgrade after that, because the policy table in 6724 is demonstrably broken from the perspective of ULA space. I am like, everybody who uses Linux and whatever else has the default gai.conf has benefited from not being upgraded from 3484 to 6724. So let's not do that. Let's update the policy table and then relegate any other changes we need to make to a separate draft that might take a lot longer. That's my opinion.
As they're saying, you say loose language sinks ships. That's quite hard to say. So what I mean by 6724 is 6724 with these updates in place, not as it is.
Sure, agreed.
Tim Winters, QA Cafe. So definitely on the configurability requirements, having written test cases for the previous version of this RFC and this version of this RFC, the configurability requirements would be really hard to move to a must. Devices are all over the map. I would not be a fan of that. I'm definitely a fan of updating the policy table. I will say right now we're testing a lot of devices and upgrading them, much to apparently Kyle's chagrin. Where that's going on right now. I don't think that's going to change anything, right? I think it's a move in the right direction, but we should definitely do something fast, because this is going to get worse as time goes on, would be my real point here. It's like, that's what we're testing right now. So I would be very cautious of that. And then the next top heuristics, I would clarify that as well, and we can put some tests in for that too.
But obviously with the experience you have and what you've been done in the past, any advice you've got on kind of encouraging towards must for the configurability would be very good.
I think should's fine. I think you're always going to have devices that aren't interfaces. It's a difficult problem to solve. I think should is actually the right answer here.
Ted Lemon. Just very briefly, I noticed there was quite a bit of discussion on the mailing list about operational use cases that nobody ever actually does. And I just wanted to mention here that I really like it if we didn't tube on those. And I think, so in other words, I'm arguing for go fast, small changes. Don't worry about these weird edge cases.
Thank you.
Dave,
Yep.
Dave, are you online?
No.
Yep. You hear me?
Yes, we do.
All right. Yeah. So +1 to the. So this is Dave Thaler as editor of RFC 6724. +1 to the comments by Jen and I think Kyle, Tim, and others, which is yes on proposed fix number 1, no as worded on both 2 and 3. Right. And it has to do with, as Jen mentioned, constrained nodes. And so I would recommend a LWIG review, meaning post this to the LWIG list if that hasn't already been done. I don't know, since I haven't been following the thread, because I think the constrained nodes, I get what you're trying to accomplish or whatever, but I believe that should is the only thing that you can do at this point. And if somebody's not going to do the should, then changing it to a must wouldn't change their mind either. Right. And so my point is yes on 1 and no on 2 and 3. Thanks.
Yeah, thanks, Dave, and hi. Yeah, so I think we put those two things in here because from the discussion and all the evidence we have, we think they're important to emphasize that they should be there. But I agree with what you're saying and what others have said here.
Yeah.
We're putting it to the room and
pointing out what the issues are is good, because you can say, here's the rationale for the should, and that type of stuff is great. That's great. That's more or less informative text, right? Saying, here's what happens if you violate the should. All that is good stuff, right? Lorenzo mentioned, stuff breaks, right? Write that down. That stuff is good because that helps to convince people who actually read documents, to actually follow the should, right? But you can't make it a must, is all my point is.
Okay, thanks, Dave.
I'm going to interject as responsible AD for LWIG. I'll say LWIG is closing down. If you want to review, you can request an IoT directory review. You can also take it to the IoT Ops working group if and when things are ready for that.
So Eric Ving, Cisco, no head here. Just 3 comments. I may suggest to have 2 documents because the first point and the last 2 points will progress at different speed, thanks to different opposition. Because I'm opposed, right, to the default policy change. Like Lorenzo, I think we need to differentiate between a global IPv4 and RFC 1918. I do prefer global IPv4, as you know, right? I'm repeating myself, compared to a ULA. Maybe I'm the only one in this room, right? That's okay. And the other point, I'm a little bit concerned about a new node having the new policy table and the old node having the old one. The traffic, the address selection will be different one way to the other. The sense that initiator is the legacy. I will use whatever. The initiator now is the more modern with your change. I will change another path. Operation-wise, this may prove complex to troubleshoot. Food for thought on this one.
Yeah, thank you.
Yeah. Okay, thank you very much. I guess we continue discussion on the list, and Lorenzo, you're next.
Okay. Okay. Lorenzo Colletti, Android. Next slide. On behalf of co-authors.
Second. Yes. Next slide.
Dare I attempt this? Oh, look, worked. Okay, so just to recap, because I presented this at last IETF. It was a little bit early because we've since made a lot of progress on the v6 ops document. But what we're trying to do here is okay, let's start with the fact that IPv6 devices almost always have multiple addresses. You got lots of them: link local, stable, privacy, 464 XLAT, ULA, multiple prefixes, renumbering, and so on. And in reality, often IPv6 stacks, of which there may be more than one in any given thing that you consider to be a device, like a phone, they share connectivity with other IPv6 stacks. VMs, containers, tethered devices, Wi-Fi calling implementations, you name it. There's lots of things in a given device today and behind it. Now, on some networks, you have scaling issues when creating, and if you want end-to-end connectivity, you need every device to have at least one address. Otherwise, you can't have end-to-end connectivity if you don't have an address, right? This is what we have today in IPv4, right? So assuming you want end-to-end connectivity, each of these have to have its own address. So on some networks, you can tolerate the load of these additional addresses without scaling issues. But on some networks, you really can't. We've seen enterprise access points which will like basically top out at 6 IP addresses per host, and they just stop forwarding traffic after that. And in any case, this is a scaling problem, right? So on other networks, on the other hand, and so for those networks, you would like to hand out a prefix to the device and just say, like, have at it. You know, use everything. This prefix is yours. Do whatever you want with it. And this is basically the HPPD, right? On other networks, there's no problem with actual scaling. Like a home network, you can create probably hundreds of neighbor cache entries on your home router, and it will continue to work because it forwards them in software, right? But in a home network, you might not have enough prefixes to hand out a 64 per device, or even any prefix per device. I mean, I live in Japan, and my ISP gives me a 64, and that's it. That's all I get. I can't even pay more for a 56 or 60, right? So this draft basically provides a way for the network to tell the device whether to attempt to get a prefix via prefix delegation. Because on the first type of network, you would want to get a prefix via PD. On the second type of network, if you do that, you just chew up all of the address space and the network runs out of space. So we're basically proposing a mechanism for the network to signal to the device, use PD or not. Next slide. How are we doing this? We have a flag in the PIO, and it basically says, if you understand this flag, don't do autoconf in this prefix. Instead, get your own prefix and do autoconf from there, right? Assign addresses from that prefix. Why in the PIO? Well, because it's actually a prefix-specific information. You might not want to do this for all prefixes. So I discussed all of this at 116, so not spending too much time on this. Next slide. So where are we? So the V6 Ops document that describes operationally how you would do PD in, say, an enterprise network is we did ask for last call this week. I think it's making good progress. A lot of the objections have been sort of addressed, I think. And now that document is making good progress, which defines sort of the operational scenario for doing this, we want to advance this draft, which provides the way of selecting this new mode, okay? Which provides a way for the network to say, please do this new thing, right? And so we've updated the draft. We added security considerations, privacy considerations. We made some sort of minor spec changes, things that were kind of already obvious, but we didn't say, like, you shouldn't like set the P flag to 1 by default if you just like configure a router, right? We say that you must do a rebind if the set of PIOs changes, and we also say the device must ignore the prefix if it's not of suitable size for Slack. There was a lot of discussion in V6 Ops about why this is necessary. In the short of it is this is kind of a feature parity. If we want to replace Slack, we need something that has at least the same capabilities. And also we said that if the device doesn't get any prefixes from PD, it can still do Slack. Next slide. And we also have, like, much more recently, based on discussions here, a couple more changes, sort of very trivial. They're going to be in the next update. Next slide. So we think that this has got enough momentum, given how the V6 Ops draft is going. We think there's enough momentum here and we would like to request adoption for this mechanism. And yeah, like to hear the thoughts of the working group.
Eric Nordmark. Eric 1. There's only 2 Erics on the list. Where's the third one? Yeah, I think this makes sense, right? I was a bit curious about one thing you said, which was around the switching sort of dynamically based on PD failing, what the dynamics will be of that. If sort of PD works, and sometimes you time out and you sort of give up and then you do Slack and whatever, it's just going to be stable. Maybe that's something.
it's for misconfigured networks where the P flag is set to 1 and it just never responds. You either basically say, okay, it's not working, or you say, you know what, you gave me A = 1, I'll just behave like a legacy host.
So maybe, yeah, specifying what failing means there might require some care, but so that it doesn't sort of flip-flop based on timing. But
yes.
But one thing I was...
Oh, so in particular, we would want to say to stop the client and not keep trying.
Yes.
Yes.
One thing I was wondering about in the sort of nested case, right, whether it's containers or whatever, right, tethering and whatnot, whether we know about advice to give about how you propagate this, because I have my laptop tethered to my phone running a VM that has Kubernetes inside, right? 4 layers of nesting. How does these flags actually propagate in that case? It's probably something we should think about.
Yeah. We had some text, and there was some strong opinions. And so we decided to, address those opinions by deleting text. We do cite, I mean, I think more sort of less tongue-in-cheek, we cite 7278, which is kind of the state of the art. And with we're sort of assuming one prefix. And with that, you basically have to do bridging. At least, though, within a node, you can reliably do bridging. And so you can put everything on one bridge, and it will work. Yes, it's not as good as, let's say, hierarchical PD or TIM's, like relayed PD and so on, but we're trying to sort of keep it simple. We did have some text there, and there was a lot of opinions, so I don't know if we want to. We cite 7278, or maybe we can take that offline.
Eric Veng, Eric number 2 or 3, depending on your count. No head here, obviously. I just want to know if we have different opinion. Will you suppress me as well as your text? No, just a joke, of course. So I like the idea, right? So that's very useful. My concern is to put into the PIO rather than into the array. For instance, I did not read the draft. In the PIO, if the A flag is not set, is set to 0, does it make sense to put the P flag to 1?
Maybe go back to that slide, I think, to the slide where the proposed solution slide, I think. So
this one.
There were first.
Yeah, first one.
The slide 3 maybe. So yeah. So I think there were 2 questions there. I think your question is like, should it be in the array? And we think this is really sort of a replacement for a given PIO, because you might want to say do slack on these other prefixes, like for ULA, for example, right? So that's written here. Should we, what should it do if A = 0? And sorry, what combination are you talking about?
A = 0 and P = 1, or do you force? Do you
No,
permit?
The draft says if P = 1, treat A as if it was 0.
Okay.
That's what it
As
says.
I said, then you not read the draft.
Yeah.
Let me clarify.
Yeah.
Ideally, I just would love to set A = 0 always, but I have legacy devices, right? We can't roll it out overnight.
Yeah.
So A = 1 will be there for old stuff, and eventually might turn it off.
I don't know if
Yeah,
it's me, because
Pascal?
the queue doesn't really say who that is. Okay, Pascal Tuber-Cisco. So yes, I do like the draft, and I hope you get your workgroup last call passed soon. My question is really the relation with the PIO. So it's a side question to the one just Eric passed, but so say I have 4 PIOs, right? And I want to set this flag in that PIO. Does it mean that the prefix I'm gonna get will be a subnet of the prefix in the PIO, or is there just no relationship between? If there is no relationship between the prefix I'm gonna get and the prefix in the PIO, then why put it in that PIO? Or Now I love the idea that it has a relationship. Now, if for instance the prefix is kind of short, but I want, there are multiple PIOs, but I want one address maybe in that prefix, but not in that one, I would check that the bit is effectively set in that prefix so as to obtain a longer prefix out of that PIO. If you see what I mean?
Yeah, no, I do see what you mean.
I'm not sure I'm 100% clear here.
I'm letting you finish.
Okay, so but my point was, I hope that's the intention, and if that's the intention, then probably the PIO is shorter than 64, because I may want a 64. If the PIO is shorter than 64, then it cannot be used for Slack, so problem solved.
That is not the intention, actually, unfortunately. The intention is that you would have a network like this where there's an on-link prefix. And if the device is in the new mode, it would obtain its own prefix. It was essentially not related to the on-link prefix. It's entirely separate. It's just a new deployment method. Now, as you say, in that sense, it's not tied to that prefix. The sense in which it is tied to that PIO is the fact that when you do this, you treat A on that prefix as if it was 0. What I'm telling you is that instead of using this prefix for autoconf, get your own prefix and do autoconf there, basically. Now, there may be other prefixes that may be, and in general, I think you would think of this, the prefix that you request is of a slack size, which is the same size as the one that's in the PIO, most likely.
Yeah.
So it's not a hierarchical relationship.
Michael or Benson. So I think with like an OpenWRT device here, as soon as you do a PD request, you will get both the ULA and the GUA. So it won't matter like what you put, like what should the host do if A equals 1, P equals 1 in the ULA prefix?
Depends on the server, but it will do what the network said, which is if A equals 1, it will use autoconf, and you can get a ULA prefix.
Right.
But kind of expensive. There's only 65,000 of them. But you could. That's up to the server, though. The network operator can configure this.
Right, but I think to the point is there will be no relation. You will just get whatever the network is configured to give you.
Yeah. Okay.
Do you specify here also that the device will get probably a lot of time more than one prefix in PD?
It's more like in V6 ops draft, because this is basically defining the prefix, like flag, right? We do not want to go into different deployment scenario in 6-man draft, right? Look in the V6 ops one.
Basically, it's telling you start PD, and then you follow 8415, right?
Yeah. Okay, I think just for sake of time, we would love to continue the discussion as a courser. Yeah, so thank you, Lawrence. Next. Share preloaded slides. Whom we have? Sorry, I'm. Okay.
Hi. Can you see me? Can you hear me?
Yes. Oh.
Great. Okay. Should I go ahead and start?
Yes, please.
Okay. So my name is Tal Mizrahi, and this is a relatively new draft about the ICMP loopback. And you'll notice it has int area in the title. But one of the first messages we got was that this would be more appropriate to discuss this in 6-man, and here we are. Next, please. Okay, so first I want to describe two use cases. The first use case is the IOM use case, and actually IOM was mentioned earlier today. So very briefly, IOM allows you to monitor and measure a domain by incorporating IOM data fields into a packet during transit. And basically the idea or the use case that we're looking at is to be able to do something very similar to ping, so that the encapsulating node, which is the node on the left here, can send kind of something like an ICMP echo and receive a response from the decapsulating node, except that we want all that IOM data that was collected along the path to be included in the reply. So that's one use case. Next slide, please. The second use case is basically a bunch of other use cases, because actually IOM was just one example, but any example where you have IPv6 extension headers, which include any information about the path, which can be updated along the path, or actually even an SRH, anything regarding the path. There are a couple of examples at the bottom here of in progress drafts. And there are probably a few more which are not mentioned here, but the idea is that basically you want the source to be able to receive back in the response the information which was in the extension headers of the forward path. So that's basically the general use case. Next slide, please. Okay, so when we say ICMP v6 loopback, what do we mean? So basically, like I said, it's a bit similar to ICMP echo. So we have a sender and a responder. We can see the ICMP loopback request, which is sent from left to right. And we can see that basically it's in blue here. We have the IPv6 header and optionally extension headers and so on. And in the reply, which we see on the bottom, basically the reply has its own IPv6 and ICMP header, but we can see that the ICMP payload includes the blue stuff, which is actually the request message at the top, including the IPv6 header and extension headers if there were any. So that means basically in the reply message, we get all the extensions and options we had in the request. And just as a side note, this is exactly how ICMP error messages work today. Okay, so that should be pretty familiar. For example, traceroute works exactly this way. So it's not a completely different concept. It's just something that can work in a very similar way to echo. Next slide, please. Okay, so there was quite a bit of discussion on the mailing list, and I'm just going to point out two of the items that were discussed. One point was whether the ICMP loopback should be implemented as a different ICMP type, or actually two new types, or whether we should use the same type as echo and just use different codes. And the problem with using just different codes is that existing implementations in some cases just ignore the code. And basically the ICMP echo reply will just be sent with the same code that the request was received with. In some cases, again, this is what happens. In other cases, the responder actually checks the code. So that was one argument for using different types, but this is still an ongoing discussion, and we'll can resolve that on the mailing list. The other discussion is also something that was mentioned today, actually. It's related to amplification. Since the reply is longer than the request, it can potentially cause an amplification, which is, by the way, very similar to all the ICMP error messages as defined today. And again, this is still under discussion. One proposal was to basically define this as a symmetric exchange where the request and the response have the exact same length. And again, this will resolve this on the list probably. Next slide, please. Okay, so as far as we are concerned, the authors, we are ready for an adoption call, and obviously there are open issues, but they can be resolved after the draft is adopted. But I think as far as we're concerned, we're ready for adoption. And I'm open to any comments or questions.
Okay, Greg.
Hi, Greg Mirsky Erickson. Thank you, Tal, for the interesting presentation. I have several questions. So, as I understand, one of the use cases is returning IAM data to the sender of ICMP request.
Right.
So, RFC 9322 defines two flags, active and loopback. And loopback seems to be very similar to what can be achieved with this new type of message.
Right.
There might be some additional information that needs to be clarified, or might be a new type of information being basically specified so that collected data along with the headers to be returned. I think that might be an easier, and that will be more applicable, because then it could be applicable to any use of IAM rather than just with ICMP. That's one my comment.
Yeah, so just to clarify the difference between the loopback flag and ICMP loopback flag is something that you set in the IOM header, and then each of the transit nodes along the path sends a response. So that's too much information, TMI. So basically, when you only want the response from the destination, the loopback flag doesn't give you that capability. And the other thing is that the loopback flag is specific to IOM, and what we're presenting here is a generic mechanism which can be used for any of the protocols we mentioned, and also to future protocols, which, anything that uses an IPv6 extension header can basically benefit from this.
Well, I would say that I personally see it otherwise, that ICMP is a very specific mechanism, and it's not applicable to, for example, LSP ping, whereas the IAM can be put on MPLS, and then it will be applicable to MPLS. And IAM can be put on any other thing and applicable to that. So basically, I see it differently. I see that IAM is more general mechanism than ICMPv6.
Okay.
Okay. And another thing is that I really wonder what's the benefit of returning just without IOM, because as you suggested that the use case for this functionality is to return extension headers as received by their responder without IOM. So what's the benefit? Because I would expect that sender of ICMP request knows extension headers because it encapsulated them. Do you see that there might be some modification of extension headers?
So as we can see in the figure in this particular slide, when you get the reply in its payload includes the entire request, including the extension headers and the options, including the IOM, all the IOM data and all that information inside. So it's all there. Yeah, it is
no,
there.
but it appears that you mentioned that even without IOM, this mechanism is useful. So I really wonder what you see as a benefit of using this mechanism without IOM.
Greg, may I suggest that we take it to the list just for sake of time, because Gore is in the queue and we have 3 minutes, so I'm sorry for interrupting.
Okay, I can just summarize. I don't see the benefit of this proposal.
Hi, Gori Fairhurst. I've got transport questions against this because this appears to be a source that you can activate remotely that generates packets. Cool, lots of things do that. Is it rate limited? Is there a rate limit implied in the rate at which you're going to respond on the return path?
So again, it's very similar to ICMP echo, and it's very similar to traceroute. So
cool. So it will be rate limited
actually,
like these are.
The very same answer you would give to ICMP echo, you can give to this. It's just a different type, and rate limiting. The very same question can be asked about ICMP echo, right?
Excellent. Please do that and think about the return path as being a different path to the forward one. And also think about multicast, because I'm a little bit scared when you say do this for multicast. So because I think everyone will respond at the same time, because that happens in multicast. So just some transport considerations when you think about it.
Okay, thanks.
Okay, thank you. I'm afraid we do not have time for if time allows. Yeah, I'm sorry, but but I guess at least one of the drafts in the time, if time allows category is now discussed on the list. I put some feedback, so I encourage people to look at that agenda and read the drafts, which we did not have time for today. Oh yeah, we are sorry, we have full agenda. So thank you very much, everyone. I will see you in Prague.
See you all in Prague. Enjoy the rest of your time in San Francisco. Generally pretty well. Except for Meet Echo, I haven't.
Which might be easier than reading. Okay, thank you, Bob, for your fantastic technical solution.
Good. Yeah, you got stable service. I had to keep restarting. I had to reload the page like
I need
4
to
times.
get one of those.
Send you the
Well,
Amazon link.
can I take the picture of this beautiful thing so I can know what to buy on Amazon?
Well, take pictures on both sides.
Okay. Thank
If
you.
you have any questions, just email me.
Yeah.
I bet you I can find the thing I bought. Good.
Good. Right, no dramas.
So, when do you want to start?
Again, probably. Still shouldn't be
Just if you look at the certification, it's a very well-known.
Standard one?
Was like a few,
so
was this 10 years ago? There was a problem, and I hope I described it.
Or mine.
So the bad news is, I think you need to change the.
We do recommend using the Ethernet because I had to restart my browser.
But I think it's early enough to do it at this point. Anyway, I put it in the mail. Yeah, I don't know if I.
Oh, okay. Oh, good. Oh, wait, this is the wrong. I have to plug that in here. That did not work for me. I don't know if it was our laptop or the thing itself. So I had my own anyway.